The bone age assessment by the analysis of hand and wrist bones has been a main tool in radiology and endocrinology, which have the aim of produce diagnosis in malnutrition and growing problems. The anatomy of the hand is divided in three regions. The first region is the carpus. It has 8 small bones named carpals. These make up the wrist. The next region are composed for the metacarpals. These are 5, one for each finger, and make up the palm of the hand. The last region is composed by the phalanges. These are 14, 3 for each finger, the proximal, the medial, and the distal phalanx, except for the thumb that just has the proximal and distal phalanx. Are two main ways to do the analysis by the specialist. The first and more common is the Greulich-Zampel method. This takes the whole hand and matches their characteristics with an atlas. It requires a great ability from the specialist to obtain reliable results. The other way is the Tanner and Whitehouse method. This one takes individual measures of a specific number of bones of the hand and gives an individual score for each one. This is a more reliable method than Greulich-Zampel, but at the execution, the specialist must do a series of calculations that demands too much time from the specialist to generate diagnosis. The first known work is from 1981, where implement an algorithm for the optimization and extraction of features by edge detection, which enhancement the pixel contrast with the aim of isolate dust of tissue from the bone tissue, doing of use of fuzzy logic operators. The experimentation is realized in a wrist radiograph. In 1986, these same authors realized a new approach were focused specifically in the syntactic recognition of the different growth levels on the hand and wrist images using fuzzy grammar and fuzzy primitives. For the automation of the process, they proposed two algorithms which use syntactic hierarchies with three statements that use 6 or 7 fractionation for their classification. The bone age assessment is done by Tanner and Whitehouse. In 1989, design and implement a model based on computational vision system which has named HANCS. HANCS segment automatically specific phalanges and measure 4 parameters: perimeters, areas, and the length of the major and minor axis. The system consists of 3 states: preprocessing, segmentation, and measuring. In the preprocessing statement, to normalize the radiography, the system uses a model based on histograms. The segmentation looks for lines and outlines based on the background of the hand edges. In the measuring phase, it quantifies the parameters obtained with the segmented image. HANCS is a tool that facilitates the measuring according to the features of the hands and wrist bones. These authors didn't consider the carpal bones. These ones are a main source of information for the assessment of the bone age in the first age of growing. In 1990, apply a technique known as Bayesian inference for edge detection, vertices and other features of the image. A sketch of the hand is used to detect the transversal edge. This is the whole hand and the junctions of the phalanges, based in a matching. Authors like Tpietka argues that this technique can be used in pediatric medical imaging because the height, position, and localization of the image may vary to this model. In 1991, provide a technique using an algorithm that defines the PROI, phalangeal region of interest. The image processing is done by creating an image of two-dimensional gradients treated with the Sobel operator in order to separate the soft tissue and bone tissue. The question dividing the PROI distal phalanges, proximal, medial, and extracting the length of each of these. To get this data is a comparison with a standard measurement chart of the same to give an estimate of age. This work is absent from the new treatment of carpal bones as well as the radius and ulna, and their method of estimation of bone age is very similar to Greulich-Zampel, which is characterized by a low effectiveness. Another study of this year propose a method that optimizes the segmentation of radiological images of hand and wrist using edge detection based on image intensity. This is proposed due to the difficult segmentation in places where bone tissue is combined with soft tissue, especially in regions of the carpus and metacarpus. This technique showed a marked improvements for image segmentation. In 1983, Pietka and other authors performed a method for extracting features of the carpal bones. Carpal region of interest detection is done automatically after the image is thresholded. Then, the system extracts each of the carpal bones and evaluates them individually, extracting measures such as perimeter area, among others. This work represents a good complement to other work, as feature extraction extends the entire hand excluding the ends of radius and ulna. The last works date from 2008. In this year, Lee and other authors make a system using fuzzy logic, fuzzy theory, providing for 7 of the 8 carpal bones, although not naming the technique used for image preprocessing. Each of the 7 bones in 5 they consider geometric features, which are the total radiocarpal bone radius, to consider a relationship between the two neighbors and to measure of compactness. Our results obtained here were compared with the results of experts' analysis manually. In 2009 is developed a software product that determines bone age skeletal maturity automatically from a digital hand X-ray. The name is Bone Expert. Traditionally, bone age is determined manually by a radiologist or pediatric endocrinologist. This is a subjective procedure and is associated with a considerable variability. A recent study by Ball showed that the standard deviation between two manual ratings of the same radiographs was 1 per 16 years in a routine clinical setting. Highly trained readers can obtain a better reproducibility, and the best reproducibility is obtained by readers using 15 minutes per image. Bone Expert eliminates this variability completely. Rewriting the same digital radiograph yields exactly the same result. In addition, Bone Expert saves time. Bone Expert computes the bone age in 5 seconds. The accuracy of Bone Expert has been demonstrated through its ability to predict adult height, where it outperforms expert raters using the TW3 or the modern Tanner-Whitehouse method. The Bone Expert evaluates many races of the world for the bone age assessment, but has the inconvenience of reject radiographies of low quality of image. In 2009, Daniela Giordano presents a work named Automatic Skeletal Bone Age Assessment by integrating the epiphysis metaphysis region of interest and carpal region of interest processing. The system that they propose consists in a fully automatic system for bone age evaluation according to the Tanner-Whitehouse 2 method, based on the integration between EM-ROI and C-ROI analysis, which ensures accurate bone age assessment for the entire age range from 0 years to 10 years. For both approaches, novel segmentation techniques will be proposed in detail. For C-ROI analysis, in addition to active contour models, derivative difference of Gaussian techniques are proposed, whereas for EM-ROI analysis, image processing techniques and geometrical features analysis based on difference of Gaussians, the OG, are introduced. The active contour models usually show shortcomings due to the initial conditions. This problem has been overtaken by a suitable preprocessing technique that allows us to extract onto well-defined carpal bones before applying the ACM, active contours method, combined with the active shape models. The ACM and ASM have been often used in the bioimaging research fields, pointed out in the 10 reference, and accordingly the automatic skeletal bone age estimation several approaches based on ACM and ASM have been proposed. An example is the method developed by S. Mammoudi, which proposed an automatic method for detecting edges and position of the phalanges by using a suitable modification of the standard ASM approach. Due to various factors, X-ray of the fat hand in general a poor contrast, and image features in the cross-sectional part are often obscured and degraded by artifacts. In order to obtain accurate and reliable feature information, we apply image preprocessing to remove artifacts and degradation such as blurring and noise. Moreover, preprocessing step for background removal and hand rotation is needed. This work has the advantage of received radiographies with low quality of image.